Welcome to the Sequence Alignment Dynamic Programming game. The objective of this game is to fill in the dynamic programming matrix to solve the global sequence alignment problem. To get the best global alignment of two sequences, we will fill in the dynamic programming matrix below for the NeedlemanWunsch algorithm. For a pair of nucleotide, match score is 20, mismatch penalty is -10, and gap penalty is -20. We are given two sequences. Sequence W, ATAAAG. Sequence V, ATAGG. Sequence W is placed horizontally, and sequence V is placed vertically. The matrix is initialized with increments of gap scores. Let us fill in the first entry. We can get to this entry from three directions. First, from the diagonal. Diagonal entry was 0 and A is a match. So we add 20. And get 20. Second, from the above, which is the value -20. The gap penalty is -20. So we subtract 20 from -20. And get -40. Third, from the left, which is the value -20. The gap penalty is -20. So we subtract 20 from -20. And get -40. From the three options, we pick the largest value, which is 20. Type in the score and press return or click on check score. The diagonal arrow is drawn. Likewise, the second entry can be filled in. The diagonal entry was -20 and A and T is a mismatch. So we subtract 10. And get -30. The top entry has the value -40 and the gap penalty is -20. So we subtract 20 from -40. And get -60. The left entry is 20 and the gap penalty is -20. So we subtract 20 from -20 and get 0. From the three options, we pick the largest value, which is 0. And the right arrow is drawn. Next, the diagonal was -40 and A is a match. So we add 20 to -40. And get -20. The left entry is 0 and the gap penalty is -20. So we get -20. The top entry was -60, so when we subtract 20 from -60, we get -80. From the three options, the largest value is -20, which was obtained both by a match and a gap in V. So both the diagonal and right arrows are drawn. We can start filling in entries below too. And T is a mismatch. So we have -30. A gap in V gives us -60. And the gap in W gives us 0. So a down arrow is drawn. Similarly, we continue to fill in the rest of the matrix. Notice that the pop-up window shows the alignment thus far. Alternatively, you can click on a fill cell to see the best alignment up to that point. If you make a mistake, we will let you know. And you can try again. We are finally done. The lower right-hand entry tells us the best alignment score, which is 50. The program traces back to give us the optimal alignment path and highlights the entries in green. An alternative path is available. And yet another alternative path is available. The game produces one of the equally optimal paths. You may choose to adjust match, mismatch, and gap scores. Or customize scores for each pairs of nucleotides. To play another game, click on the blue New Game button. And you can choose different levels, with level 3 producing largest matrix. Enjoy!